Okay, beta. So today we will discuss chapter 9, Science, Light, Reflection and Refraction. Today we will discuss the questions of this chapter. Okay, numericals and all other things. So beta, for discussing or solving the numericals related to this chapter, first of all we need to know certain things like the mirror formula, lens formula, and the sign convention for the mirror and the sign convention for the lens. Then you can answer the questions only. Okay. So first we will discuss those things which are important when we are solving the numerical related to the refraction and reflection. Okay. So let's discuss. Let us discuss. Have you remember this? Because actually this one is important. So the beta first it is about the mirror. Okay, so we will discuss the mirror formula. First of all we will know about the mirror formula and the magnification related to the mirror. So what is mirror formula? Mirror formula is 1 upon V one upon V plus 1 upon U is equals to 1 upon F. This is mirror formula. Mirror formula. Do you know what is V, U and F here? What is V?
V is equal to distance of image. Sorry, distance of object. And U is equal to distance of image. No, sir. V is equal to distance of image.
Is distance of image.
Yes, sir. U is equal to distance of object.
U is distance of object. F is focal length. F is focal length. Okay. Always remember these things while you are solving the numericals. This is the mirror formula and this is V, U and F. Okay. And there are more things that we need to know other than mirror formula and V, U and F. Sign convention. Sign convention means while you are taking, suppose you have given an image, an object is this much at the distance of this much from the mirror, then you have to put the sign plus or minus in front of the distance of that object. What will be the sign there? You will know it by sign convention. Look at beta. This is the mirror. You can take it as a y-axis. This mirror as a y-axis, and this one is the principal axis as a x-axis. Okay. all the all the values. First of all, you have to know the object is always left of the mirror. You will always suppose that the object is left of the mirror. Okay, object is always will always in the left of the mirror. Okay, and you have studied in the coordinate geometry. Suppose this one is the x-axis and this one is the y-axis. Then all the values left of the y-axis is negative and right of this axis is positive. So all the values, this side will be take negative value and this side will take positive values, whether it is the object or image. This side negative value, this side positive value, means object will always take a negative value. As I told, always is always left of the mirror. So always will object will always take the negative value. In any mirror, convex or concave, there are two types of mirror, na? In any mirror, object will always take negative value. Okay. Similarly, the value above the x-axis will take positive value and below the x-axis will take negative value. Okay, object is always upside of the x-axis, so object will always take positive value in terms of its height. In terms of its height, because this value will represent the height of the object, na? This value represents the distance of the object from the mirror and this value will represent height. So distance of the object will always negative and height of the object will always be positive. Okay, so this is the sign convention. Here is the magnification. You know what is magnification? When you divide height of the image by height of the object, you will get magnification. Okay, that is height of the image divided by height of the object. You can also write it like this. Okay, minus v by u. Minus v by u also give you magnification. Okay. In the case of mirror, this is only for the case of mirror. When you divide height of image by height of the object, you will get magnification. Means magnification gives you idea कि how the image is either smaller than the object or the bigger than the object or the same size. Okay. And it also gives you the idea about it is inverted or erect, not real or virtual but inverted or erect. Okay, so minus v by u also give the magnification. Okay, remember it. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. It is a question here. Find the focal length of the convex mirror whose radius of curvature is 32 centimeter. Can you find it? We know that there is a relation between the radius and the focal length, na? What is that relation, Aman? What? Radius of curvature. Radius of an curvature and the focal length of the mirror is related. F is equals to R by 2. So by that, by applying that, you can find it, right? We know that F is equals to R by 2. Here we need to find focal length and radius of curvature is 32 centimeter. F is equals to 32 by 2, that will be equals to 16 centimeter. Okay beta? Now a concave mirror produces 3 times magnified real image of an object. Place 10 centimeter in front of it. Where is the image located? Can you find it?
Second one.
Yes.
The concave mirror 3 times magnified. Magnification is 3 times.
Yes.
Really.
So first of all we will discuss them. We will discuss them. So here it is telling about the concave mirror, na? Always remember that the focal length of the concave mirror, the focal length of the is always negative. Focal length of the concave mirror is always negative. And the focal length of the convex mirror is always positive.
Yes. Concave
Image distance is always negative for concave mirror, or either is concave or convex. Image distance is always negative. Object distance is always negative. Yes. And focal length of the concave mirror is always negative, and convex mirror is always positive. Focal length. You have to remember these things, because if you will not remember it, you cannot solve the questions like this. Okay. You know the lens formula? Do you know lens formula? What?
1 by x equal to 1 by minus 1 by
What?
length formula. 1 by x equal to 1 by v minus 1 by u.
1 by v minus 1 by u is equals to 1 by f. Our magnification here is v by u. Okay. In the case of mirror, there is a minus sign here. In case of the lens, there is no minus sign here. Discussing about the focal length. In case of
concave mirror, it is negative.
It is negative.
And convex mirror is
Positive. Opposite of the mirror. It is lens, na? For concave lens, it is always negative. Focal length is always negative in the concave lens and always positive in the convex lens. Okay, negative U, object, always negative. Object distance is always, and image distance depend on which type of image is there. There is a relation between power and focal length. P is equals to 1 by F. The SI unit of power is diopter. If the focal length is in meter, you will get the value of the in diopter. Define one diopter of power of a lens. Define one diopter. 1 diopter of power of lens. What is 1 diopter power? We know that P is equals to 1 by F, and if the value of F should be in meter, the unit of F should be meter, then you will get the value in diopter only. Okay, if F is equals to 1 meter, you will get P is equals to 1 by 1, that is equals to 1 diopter. Okay, so answer will be, if the focal length is 1 meter, the length of the power is 1 diopter. If the focal length of a lens is 1 meter, the power of the lens is 1 diopter. Okay. Now, next question. A convex lens form a real and inverted image of a needle at a distance of 50 cm from it. Where is the needle placed in front of the convex lens if the image is equal to the size of the object? Also find the power of the lens.
Convex lens per positive real lens in particular to magnification lens के बात है.
Yes, a convex lens form a real and inverted image. Which lens form real and inverted image? Convex. It is already given that a convex lens forms a real and inverted image of a needle at a distance of 50 cm from it. Means 50 centimeter is
Distance.
whose distance? No. A convex lens form a real and inverted image of a needle at a distance of 50 centimeter. It is V.
Yes.
It is V, right? A lens is convex, so we will be positive or negative? Positive. Okay. So 50 centimeter. Okay. V is 50 centimeter. Where is needle placed in front of the convex lens if the image is equal to the size of the object? Here it is given that the image is equals to the size of the object. Yes. If the object is at the center of curvature, then the image is also form center of curvature and the size is same. So beta, the V is 50 centimeter, or you can say कि radius of curvature. In this case, we can say कि radius of curvature is 50 centimeter, because it is saying that the height of object is equals to the height of image. It is only possible when the image and object both are, if the object is on the center of curvature. So we can say that 50 centimeter is center of curvature. The focal length is 25 centimeter. Okay. Also find the power of the lens. By finding F, you can find power. Power will be 4 diopter. No, not a 4. Focal length will be 25 centimeter. That is equals to 0.25 meter. 4 diopter. Power will be the 4 diopter. So where is the needle placed in front of the convex lens? At the distance of 50 centimeter. And power of the lens is 4 diopter, because radius of curvature is 50 na, the focal length will be 0.25 meter and 25 centimeter means 0.25 meter. and then you will find P is equals to 1 upon 0.525, that will be equals to 4 diopter. Find the power of a concave lens of focal length 2 meter.
Find the power of concave lens of focal length 2. Then minus 2 here concave. So concave lens.
Yes. Concave lens, in the case of concave lens, focal length is negative.
P is equal to minus 2.
That will be equals to minus 0.5 diopter. Okay. So let's move to the exercises.
Yes.
If there is any problem in the in-text question, we will make a separate class for that, okay? Today I just discussed this. We are going to solve exercises today. So let's see beta, which of the following material cannot be used to make a lens? Which material cannot be used to make a lens? Water, glass, plastic, clay. Beta, the material that allow light to pass can be used as lens. Okay?
Yes.
Clay. Because clay do not allow light to pass. Okay? Any material that allow light to pass can be used as a lens. So water, glass and plastic, these things allow light to pass through them. So right answer is clay, because clay do not allow light to pass through it. The image formed by a concave mirror is observed to be virtual, erect and large. Mirror is concave. Note this point, mirror is concave and image is virtual, erect and large. In case of concave mirror, there is only one case when it forms virtual image, right? When the object is between F and P, right?
Focal length and principal axis.
There is only one case. That's why I told you sometimes before ki always remember the image formation by all the mirrors and lenses. There is only one case in the concave mirror where image is virtual. When you place the object between pole and focal,
Yes.
you will get virtual and erect. So between pole of the mirror and principal focus, right?
Between pole and the mirror.
Okay. Third one. Where should an object be placed in front of a convex lens? The lens is convex. Okay.
To get real image.
To get a real image of the size of the object, of the size. But in all the cases of the convex lens always form a real image. No. In one case it forms virtual image. देखो, concave mirror forms virtual image in one case and convex lens form virtual image in one case. The cases are same when the object is between pole and focals, principal focus. If the object is between pole and principal focus, concave mirror form virtual erect, and if the image is between pole and focus, convex lens form virtual and erect. Okay? So one case only. So where should an object be placed in front of convex lens to get real image of the size of the object? Here we have to find the real image. So real image and the size must be same here, na? Real image of the same size of the object. Image must be the size. So size means that should be on the center of curvature. So here there is no option of center of curvature, but we know that ki F is equals to
2c.
r by 2 yet c by 2, or 2f is equals to r. Radius of curvature or center of curvature are same thing. So twice the focal length. Okay beta,
Yes.
twice the focal length. Okay. Question number 4. A spherical mirror have a thin spherical lens, have each a focal length minus 15 centimeter. The mirror and the lens are likely to be. A spherical mirror and a thin spherical lens have focal length minus 15.
The
Here,
mirror and the lens both, which has the focal length is minus.
here we need to notice that focal length is negative.
Yes.
Focal length is negative. In which case, in which mirror focal length is negative? Concave. Or in which lens focal length is negative?
Concave.
Concave. So concave. Both are concave. Both concave. Both convex. Both concave, right? Is there any doubt? No matter how far you stand from a mirror, your image appears erect. The mirror is likely to be. Image is always erect. Your image appears erect. In which mirror image is always erect? Can you tell me? You have studied two spherical mirrors here, na? A concave and convex. So in which mirror? Convex. So in case of convex mirror, the image is always erect. So let's see the option. Only plane. Yes. In plane mirror, the image is always erect. So let's see the options first, na? Only plane, only concave, only convex, either plane or convex. So this option will be, because in the plane mirror, image is erect always, and in concave, convex mirror, it is always erect. So the D1. Okay. Okay, the question number 6. Which of the following lenses would you prefer to use while reading a small letter found in dictionary? The small letter is small, so you have to enlarge it. So which mirror makes, or which lens enlarge the image? Convex lens. So there are focal length also here. Convex lens focal length 50, convex lens focal length 5.
50 कर देंगे तो ज़्यादा बढ़ा देंगे.
Beta, the smaller focal length, greater the power. What?
The smaller focal length.
P is inversely proportional to the F. Oh, sorry. Yes. P is inversely proportional to the F. Okay. So this option is focal length 5 centimeter. Okay. Now let's move to the question number 7. We wish to obtain an erect image of an object. we have to obtain erect image using a concave mirror of focal length 15 centimeter. Concave mirror is there.
Yes, sir. Erect and ली हुई है and concave mirror है, focal length 15 है तो -15 रहेगा.
Concave mirror and erect image. Concave mirror and is only in one case, na? When between P and F. Object is between P and F. In that case, concave mirror produce erect image, right? And virtual also. Focal length is 15 centimeter. So what should be the range of distance of the object from the mirror? What is the nature of the image? What should be the range of the distance? That will be equals to 0 to 15, right?
Yes.
0 to 15 centimeter. Okay. Or you can say greater than 0, less than 15. Okay. Greater than 0, less than 15.
What is the nature of the image?
You can write it between.
Sir,
What?
already mentioned here the nature of the image is erect.
Between 0 to 15. Okay. Right answer is between, because we have to exclude 0 and 15.
Yes.
What is the nature? Virtual?
Virtual. Erect, yes.
Okay. Virtual and erect. Is the image larger or smaller than the object?
Is the image larger and
Larger, na?
yes.
Larger. The nature is virtual and erect. Nature is virtual and erect. Okay. The image is smaller and larger. Larger. Okay. So between 0 to 15, answer of what should be the range of the distance of the object from the mirror? Between 0 to 15. What is the nature of the image? Virtual and erect. Is the image larger or smaller than the object? Larger. Okay. Let's move to the question number 8. Name the type of mirror used in the following situation. Headlight of a car.
Concave mirrors.
Mirror.
Concave mirror.
Concave mirror. Why beta? Do you know the reason?
सर क्योंकि lateral inversion होता है.
Lateral inversion होता है. Concave mirror. So what is the use of lateral inversion in the case of headlight of car?
सर जैसे कोई जैसे एम्बुलेंस आ रही है तो उसमें से अगर मिरर से कुछ सीधा नहीं है और ऐसे में लेकिन
It is the headlight of a car,
yes headlight.
not the rear mirror.
Headlight.
The case you are mentioning is the case for the rear mirror of a car, right? Yes. Headlight of a car. Headlight of a car we should use concave. Why concave? Because it is converging mirror. What? It is converging mirrors. And when anything passes from the infinity goes parallel to the principal axis, means all the beam of the light will goes parallel. Okay. And we have to converge. Generally, you can see ki the light of headlight of the car focus, right? That's why the concave mirror. Side and rear view.
Side and rear view of the vehicle is convex.
Convex mirror. Okay. In this question you can mention that reason you were mentioning before. Because first of all it forms small images, so you can see all the vehicles that are behind your car, right? Whether it is very near to your vehicle, the full image of that vehicle will be formed in your side mirror. Solar furnace. Once a concave mirror, once again concave mirror. The plates on the solar plate. Have you ever seen or heard about the solar panel? That is solar furnace. It is used to utilize the solar energy, sun's energy. Once again, it need to focus at one point, na? The converging mirror is required, the concave. Okay? Let's move to the question number 9. One half of a convex lens is covered with black paper. Will this lens produce a complete image of the object? Verify your answer experimentally. Explain your observations.
Half of the convex lens is covered with black paper.
What do you think? One half of a convex lens is covered with black paper. Okay, beta. Suppose कि one half of it is covered. This region is covered with black paper. Okay. Then will it produce the full image? Yes. It will produce full image, because suppose this one is the object, okay? Here is F, and here is C, okay? You can see कि if you put the object, if the object is at infinity, a parallel beam will go to the focus, right? And suppose कि you are passing other at optical center, okay? So it will go without any diversion, deflection, okay? So you can see that the image will be formed here, right, beta?
Yes.
This will be your image. So this part does not affect the formation of image. ऊपर वाले भी करेंगे तो same. If you cover the upper region, the same thing will be happen from the lower region. Okay. So no effect will be produced. Okay. One half of the convex lens is covered with the black paper. Will the lens produce complete image? Yes. Yes. Right, beta?
Yes.
Yes. Verify your answer experimentally. You will draw the ray diagram like this. You will draw ray diagram. I have drawn for one case. Okay. You will draw two cases. In first case, this will be the cover. In the second. So better next part we will discuss in the next class, okay? फिफ्थ भी डिस्कस कर ही लेंगे, 11th वाला भी 11th भी डिस्कस कर लें, छोटा है बहुत बड़ा नहीं है।